Alright guys, if Mrs. Bryden chose to have you do your lesson 69 homework with me here on the video, then let's go ahead and set up our paper for lesson 69 homework, and I will walk you through the solutions to the 18 problems that we have here for lesson 69. So I've got problems 1 through 8, 13, A, B, C, and D, 15, 20, and 27 through 30. Okay, so let's go ahead and start here with number 1, where I am supposed to combine, if possible, the following: negative 6 square root 2 plus 8 times the square root of 2. Both of these square roots of 2, okay, I've got identical radicals here, so I can combine the coefficients. So I get negative 6 plus 8 equals 2 square root of 2. Okay, number 2. If you want to put that in an answer column, fine. If not, that's okay too. Just make sure that I can see your answer clearly. Okay? Okay, for number 2, I've got negative 4 times the square root of 7 minus 5 times the square root of 7. Now, because both of these radicals are the same, I can combine the coefficients. I have minus 4 minus 5, which gives me a total of negative 9 square root 7. So that's my answer there. Again, if you want to put it over here in an answer column, fine. If not, just make sure I can see it. Number 3, 2 times the square root of 3 plus 5 times the square root of 3. Radicals are the same, so I can combine the coefficients. 2 plus 5 makes 7 total packages of the square root of 3. Here in my answer column, I've got 7 times the square root of 3. Okay, number 4. Determine the degree. So the degree of this monomial, 9x, remember coefficients do not have a degree. The only thing that has a degree is the variable, and this has an implied exponent of 1, which means that the degree is just the exponent there. So the degree of this monomial is 1. Okay? My answer column, I just write 1. For number 5, what they're asking here, when I've got this trinomial, okay, negative 3x squared plus 2x plus 16 is for the highest degree, the term with the highest degree. Okay, so which one is it? This doesn't have a degree at all because it's just a coefficient. This term has a degree of, so this is nothing. Okay, this has a degree of 1 because this x has an implied exponent of 1. This term has a degree of 2 because I've got an x squared here. So the highest degree here in this trinomial is 2. That's the answer. Okay, I've just determined the degree there of the term with the highest degree. And now I'm going to go on to number 6, xy plus 2. There is no degree here to this coefficient. X has an implied exponent of 1. Y has an implied exponent of 1. When I add those two together, because that's what I do to figure out what the degree level is, right? This has a degree of 2. So the answer here is also 2. Okay, this term, the highest degree of the terms there in the trinomial, of this binomial is 2. Okay, let's move on to a little bit of probability here in number 7. What is the probability of rolling a sum of 12 with 2 number cubes? A sum of 12 with 2 number cubes. Okay, we got to think about this, and we don't have our handy dandy little chart in here anymore, although I think I can grab one. Yeah. Okay guys, here's our chart. This is our chart, 2 number cubes, the probability of rolling a sum of 2 or a sum of 12. So the sum of 2, there was just one chance here in our 36 chances. Remember how we had 36 chances? There's one chance to roll 2. You'd have to get a 1 and a 1. And in order to get a 12, you have to get a 6 and a 6. There's only one chance in 36 that you'll get that. Okay, so on my probability here, the probability of rolling a sum of 2 is 1 in 36. And the probability of rolling a sum of 12 is also 1 in 36. So to get the probability of rolling one or the other, I add those two together. I get 1 in 36 plus 1 in 36, which gives me 2 in 36, which is going to reduce down here to 1 in 18. That's the answer. Okay, so for number 7, the answer is I have a 1 in 18 chance of rolling either a sum of 2 or a sum of 12 with 2 number cubes. Okay, number 8, rolling a sum greater than 1. Okay, let me go back to my little chart here, as you saw this, right? So you'll notice that it's impossible to roll anything less than a 2. Right? I've got 2 cubes. The very least I can roll is a 2. So every single roll is going to be greater, right? Greater than 1. So I have a 36 in 36 chance of rolling something greater than 1. When I reduce that down, I get 1. The probability of rolling something greater than a sum greater than 1 is a full 1, a 100% chance is what that's saying. Okay? All right, let's go on now to number 13. In number 13, we've got Luke. Oh, we've got one of these guys again. Okay. The find the shaded area deal, right? You don't have to redraw this. I just think it's helpful to see, so I'm going to draw it here for us. Okay, Luke's building a new fence around his property. I know that from here to here, this distance is x, and from here to here, this distance is x. Okay, because I can see it there in the picture in the book. And I can see here in this shaded area, which is blue in my book, that the distance here, from here to here, is 5 feet. And the distance from here to here, right there, is 5 feet. Okay? So they're asking us to write an expression for the area of the shaded region. And they're going to take us through it one step at a time. So here's letter A. Okay, so for letter A, it says write an area of the smaller square. That's this square right here. Area is side times side, right? So it's a square, so each side is x. So area equals side squared. So in this case, all I know is that area is x, so area is x squared. That's the expression. That's the answer. Okay, so A over here in my answer column for 13A is x squared. That's the expression. For letter B, write an expression for the area of the larger square using special products. Don't worry too much about what that means, okay? It just, I'll explain it to you as we go. Okay, so here's x, right? And I know that this distance is 5 and this distance is 5. So that means that from here to here, I've got, and from here to here, from both of them, right? Because I've got x here and I've got 5 here and 5 here, that this larger square is 6 plus 10 on both sides. I mean, x plus 10, sorry. Can I write sideways? Did I do it? Yes, I'm amazing. Okay, 6 plus 10 and 6 plus 10. So to get the area then of the larger square, I'm going to need to multiply 6 plus 10 by, oh gosh, I keep saying 6, x plus 10 times x plus 10. Okay, so that's an expression for the area of the larger square, and that's it. That's the special product. Remember, a plus b times a plus b. We've got a way to multiply those. We'll do that here in just a second. But the answer for B is just x plus 10 times x plus 10. Okay, for C now, they want us to go ahead and simplify this, meaning do the multiplication. And we should remember that for an a plus b times a plus b binomial, you guys remember this? The answer is going to take the form of a squared plus 2ab plus b squared. Okay, or I can do FOIL, either way. But in any case, this is a, so it's going to be x squared plus 2 times whatever these two things are. So I've got a 10x and another 10x, so it's going to be 20x. Plus b squared, which is 100. Okay, so that's the answer for letter C. I could have done that by distributing or by doing FOIL, right? The first two terms, x times x is x squared. The outer, x times 10 is 10x, plus the inner, x times 10 is 10x. That's how I got the 20x. Plus the last two terms multiplied by each other, which is 10 times 10, and that's how I could get 100. Okay, so that's the answer for that, is x squared plus 20x plus 100. Finally then, for letter D, they want an expression of the area of the shaded region, just this little thing out here. So basically what I need to do is I need to do the area of the whole big square, and I need to subtract out the area of the smaller square, and then I'll end up with what's left over, what's in that shaded region. So here's the area of the big square, that's what I just did. X squared plus 20x plus 100, that's the big one. Subtract out what's here in the center minus x squared, that's what was in the middle, and I will get an expression for the area of what's left over, which is in that shaded region. I can combine, the only like terms I have in here are x squared, and check this out. I've got plus x squared minus x squared, so they just cancel each other out. And the area of the shaded region becomes 20x plus 100. Okay, square feet, because we're dealing with feet. And now we actually have an area, and that's it. All right, so I've got 20x plus 100 square feet. All right, good work, guys. I'm gonna turn my paper over. And we finished, let's see, number 13, and we're on now to number 15. Okay, myself all situated here. And number 15, solve the system of linear equations below. So here are my two equations, 6x plus 15y equals 15. And my second equation is 7x minus 3y equals negative 3. Okay, in order to solve this system of equations, I could do this any way I wanted. I could try to rewrite one of these equations in terms of one variable. I could do some substitution that way, but here's what I see. I see plus 15y here and minus 3y here. And I can see that if I just multiply this whole second equation by 5, I'm going to end up with a negative 15y, and I can solve this through elimination. So that's what I'm going to do. I'm going to leave this equation alone, 6x plus 15y. I just want to get rid of that y. And I'm going to multiply this entire thing. I'm going to remember that I've got to distribute to every single term. So I have 5 times 7x, so I've got 35x. 5 times negative 3y is negative 15y. And 5 times negative 3 is negative 15. Now when I add these together, I get 15 minus 15, which is 0. 15y minus 15y is nothing. Those are gone. And now I've got 35x and 6 more x's. So I have 41x equals 0. When I divide by 41, and some of you are going to say, you can't divide. Yes, you can. You can divide 0 by 41. It's not undefined, because 0 is not in the denominator, it's in the numerator, so that just means that x equals 0. Okay? I'm not done yet. I need an ordered pair for a solution. So I'm going to take 0 and stick it back into one of these equations. I'm going to put it in the top one. 0 plus 15y equals 15. 6 times 0 is just 0, so I've got 15y equals 15. Divide both sides by 15, and we get y equals 1. So my solution set is an ordered pair x and then y, so 0, 1. That's the answer. Okay, if I put that in an answer column over here, then I will list it this way. All right. Okay, that's number 15. Just a few more problems left. Problem number 20. Which graph represents the solution to x plus 6 is greater than or equal to 2x minus 12? In order to solve this, I need to move some terms around to get x just by itself on one side, right? Okay, so I think I'm going to subtract this x so that I keep x positive over here. I end up with 6 is greater than or equal to x minus 12. Then I'm going to add the 12 so that I can get rid of it on this side and move it over here to this side. And I end up with 18 is greater than or equal to x. Now I'm going to check out my possible solutions here, A, B, C, and D. It's greater than or equal to, so I know the dot needs to be filled in and it needs to be at 18. So my only two possibilities are B and D, right? Because I've got a dot at 18. And here I want x to be greater than, is that right? Or equal to, did I get my x on the right side? Oh, excuse me, not greater than, x is over here, less than. X is less than or equal to 18. That's the thing that I needed to make sure that I saw. And there's actually only one with an 18, isn't there? Just letter B, and sure enough, all of the x values, that dot is filled in and all of the x values are moving to the left, so x is less than or equal to 18, so that is graph letter B. On my answer chart, answer column here, I'll just write letter B. Okay, a few more to go. Problem number 27, I'm going to turn the page. True or false? For the set of integers, square root of x to the n power can be simplified if x, okay, so if x is greater than or equal to 0, and if n is greater than or equal to 2. Okay, let's think about this. If x is greater than 0, if there was a 0 in here, we'd have a problem, right? Okay, well, I guess we could just make it actually, no, we wouldn't, because then anything that is to our, well, anyway, okay, if x has to be greater than or equal to 0. The point is it can't be negative. If n is greater than or equal to 2, could this possibly be simplified? And the answer, when I think through this, is yes. As long as n is 2 or more, then I should be able to pull out at least 2 of these x's out of the radical. If it's an even number, then I'll pull out however many, right, squares I've got in there. And if it's an odd number, let's just say it's a 3, say x to the x cubed, I could pull out at least one x. I'd have one x still in there, but it could be simplified. Okay, so the answer to number 27 is true. And I'm just going to say right here, C, student answers. Do not write that on your paper, but explain to me what we just talked about here, okay? That as long as n is greater than 2, then at least that many x's can be simplified outside of that radical sign, okay? So help me, give me some words there that explain to me that you understand that concept. Okay, number 28, 3 more problems left, guys. Mrs. Nguyen asks her students if they can combine the radicals in the expression, okay, here it is, here's the expression, square root of 13x plus square root of 23x minus the square root of 33x. Student A says it's possible. Student B says that the radicals in the expression square root of 13x plus square root of 23x minus the square root of 33x do not combine. Which student is correct? And then explain the error. Okay, so the answer for this one, gang, as we look at this, is the question we have to ask ourselves is, can these be simplified anymore in such a way that we've got a square in here where we can pull one of those numbers outside of the radical? And the answer is no. These are as simplified as they get. right? Because these are prime numbers. So there's no way that I'm pulling another number that there are two numbers inside of any of these that multiplied by each other will give me any factor of these. Okay? So student, which is a student who said it was impossible? It was student B, right? Student B is correct. And student B is correct because each of these radicals is in its simplest form, and because each one is different, they cannot be combined. Okay, so I'm going to see the same thing here. I'm going to write C student answers so that I can see as you write that out, paraphrase that. Let me know in your own words why those cannot be combined. All right, number 29. Estimate the sum of the square root of 51 plus the square root of 63 plus the square root of 83 plus the square root of 104. Okay, if I want to estimate the sum of these, I want to think about what's the closest square root. So the closest square root I can think of to square root of 51 is the square root of 49. That's as close as I'm going to get, which is 7. Closest square root I can think of to the square root of 63 is the square root of 64, right? Okay, that's pretty close, which is 8. Closest square root to 83 that I can think of is 81. I know that the square root of 81 is 9. And 104 is pretty close to the square root of 100, which is 10. 10 plus 9 plus 8 plus 7, so 7 plus 8 is 15, plus 10 is 25, plus 9 is 34. Okay, so the answer for number 29 is, and it said estimate, so I'm going to say approximately 34. When I add 7, 8, 9, and 10, I get about 34. Okay, last problem, and then we are done with the homework for number 39, which is number 30. You're going to need to look in your books for this, guys, okay? So you've got a picture of a pyramid here. The four sides of the base of the pyramid measure 756 feet. Okay, each of the four sides is 756 feet. If a scale model is made with the measurement of the square root of 756 inches for each side of the base, how many inches is the perimeter of the base of the scale model of the pyramid rounded to the nearest whole number? Okay, so I've got my pyramid here. This should be a square. There's the square base, right? And I've got my pyramid there. And each one of these sides in this scale model is the square root of 756, each one. Inches. I am going to do this, because I can, on my calculator. Okay, so what is the square root? So I'm going to go second and then square, because that's where my square root's going to come in. What's the square root of 756? I'm going to close the parentheses. That's going to give me the estimate of one side length. Is 27.5, about 27.5. So each side is approximately 27.5 inches. So the perimeter is 4 times this. Right? 4 times, I've got 4 lengths, 27.5. So when I do that, I get that this is about, okay, it's approximately 110 inches. It's fine to take the square root on your calculator that way. Okay, guys? So over here in my answer column, I'm going to say that the perimeter is 110 inches. All right, that is it for our homework for lesson 69. So if you did all of that along with me, and you wrote good solid answers here explaining why those things were possible or impossible, then you are done. And I am looking forward to seeing you soon. I've got one more lesson that'll be a video lesson, and that is lesson 70. If you're all caught up, then you don't have any homework tonight as long as you did this with me in class, okay? If you have missing homework or corrections to do, please take the time, since today theoretically is a Wednesday, is a block day, please take the time to catch up on those corrections because you've got a test coming up soon and I don't want you to have to scramble for those. So I'm looking forward to seeing you guys soon. If you did this with me, then you have no homework unless you want to take some time to catch up on corrections. Otherwise, I will see you on video for lesson 70.